Hi everyone, this is the math call. Okay, we go for next lessons. Today lesson is the graph of rational functions. Maybe you used to learn already from last year, right? When you were grade 10. But if not, we just learn it here now. But again, anyway, I will teach you the way how to plot graph, which is a fast, and we don't need to use a table. Like before, when you plot this kind of graph, you will draw the table like this, correct? You're going to draw like this, say X and Y, and then you start from 0, 1, 2, 1, 2, 3, and so on, -1, -2, like this. And then you plot one at a time, correct? But now I don't want you doing this way anymore because this is like a children doing now, okay? So I want you plot fast and effective to get the main idea, that's all, it's enough, okay? So first of all, if you plot, every time when you plot graph for this kind of function, like a rational function, if linear polynomial, you know, I think, right? And the cube function, something like that, okay? But one concern about the rational functions, you have to consider more. They have different. So when you have the rational function, you have to consider about the plot graph faster, right? So have to do by you find asymptote. First you find asymptote, second you find x-intercept, y-intercept, and then you plot graph, right? When you get intercept, and you plot side by side, left and right hand, maybe one or 2 points for each side, and that's all is enough. That's the way to do. Okay, now we start how to plot this one. First, we find asymptote first. Okay, how to get the asymptote? Asymptote we have so far you're going to learn only two kind of asymptotes, okay, in your level. One is a horizontal asymptote, second one vertical asymptote, and third one is called slant or oblique asymptotes, okay? So in this function, rational function, you see, rational function, another word is like a fraction, okay, like come out like I have denominator. This one, the 3 is a numerator, and the bottom we call denominator. Okay, so now we find asymptote. The most easy and can see right away is here. X minus 2 is the denominator. We want this one, we want to find the vertical asymptote. You must write down vertical, horizontal. You must write, okay? Must write down vertical asymptote. How we get this one? You just how vertical asymptote you get by get x minus 2 equal to 0. Then from here you will get x equal to 2. So now we know right away vertical asymptote is at x equal to 2. Okay, we leave that way first. Okay, now we go to get the horizontal asymptote. Okay, horizontal asymptote you get from, you see the numerator, 3 is a numerator, right? And x minus 2 is the denominator. So you see the higher degree. High degree for the top one numerator, 3. 3 means we have x power 0, right? X, anything base, any base, x is a real number. When you have power 0, no matter plus or minus, okay, it's a real numbers. When you have power 0, it's equal to 1, correct? And the bottom here, we have x minus 2. Then you observe the degree, okay? You observe the degree. If this one is power 0, this one power 1, right? If the top less than the bottom one, then the horizontal asymptote means y equal to 0. So horizontal asymptote, we got it here, y equal to 0. Okay, so then next one, we're gonna get the slant, the oblique, or oblique, O-B-L-I-Q-U-E, asymptote. So how to get this one? In this case, we don't have. Why? Because if you got this one, the degree on the top, like x power 3, the degree here should higher than the degree on the bottom, at least 1 degree. Okay, if for example, I have like this, x power 2, okay, over x minus 2, like this, we have slant asymptote, okay, which is equal to x. And this one, how to get slant, we talk later, you can just do the long division. Okay, do long division, I think everyone learned already. So I leave it that way because in this question, the example doesn't have slange or oblique asymptote, but they do have vertical and horizontal asymptote. Okay, now we plot graph. How to plot graph? Fast and effective. Okay, I don't want you to like a table anymore. I tell you how, just this x-intercept. X-intercept, sorry. If you want to find x-intercept, that means y equal to 0. Okay, so gx is like a y already. G of x mean y already, right? So you just replace g of x becomes 0 equal to 3 over x minus 2. Then you cross multiplication. This one what you have. So 0 times x, this one become this way. So this 0 times 0, 0, it's this one. When you see this one, they're not equal. Okay, then we can say no x-intercept. So this one no x-intercept. Now we go next to find y-intercept. Y-intercept means x becomes 0. Okay, just opposite, convert, inverse. Okay, so y-intercept, that means x becomes 0. So from here, right, y-intercept, x becomes 0. So you replace g of x means like a y, right? So I write down here. And x becomes 0, so you have 3, the top is a 3, right? Over x 0 minus 2. So you have minus 3 over 2, negative 3 over 2. So you get y-intercept. When you have y-intercept means the whole thing you must write in the coordinate pair, okay? So that means your y-intercept equal to x 0, you write like this, and y is a negative 1 over 2. Okay, when you got intercept, y-intercept, you know vertical asymptote, horizontal asymptote already, then you start to plot graph. Okay, so now how to plot graph? See, for this one. So we lay it down, like now we draw this one first, vertical asymptote, I use the blue color, okay, now. So x equal to 2, right, this is a 0 here. Assume 1 here, 2 here, 3 here. So 2 is here, right? So this is a vertical asymptote. So you draw one line at x equal to 2. Okay. And this one have to be the vocal line, okay? So you like vocal line here. So I use the black color here. Draw the vocal line. Because asymptote means when you plot graph, the graph will approach closer to asymptote line, but never touch. Just only approach closer and closer, that's it. Okay, never touch, but they will approach as close as they can, but never touch. So this one x equal to 2. This is a vertical asymptote. Okay, I use the same color here. Now we use a horizontal asymptote, so I use the pink color here. Okay, so horizontal asymptote, that means y equal to 2. Y equal to 0, right? So 0 is right here, right? So this is like the vocal line here. This is a y equal to 0. Okay, so this is a vocal line here, y equal to 0. So once you plot all the asymptote line finish, you go to plot the x-intercept. X-intercept we don't have, so leave it. Y-intercept we have 0 and go down negative 2 or 2, that means 1.5, right? And idea is enough. Okay, so I get this one, maybe 2 here. So this is a y-intercept point, negative 3 over 2. Okay, now we start. We know all this one already. Now you start to plot graph. When you know asymptote here, vertical and horizontal, right away you will know where the graph gonna go. Graph can be either on the top here, approach to asymptote, and the bottom approach to asymptote, or can be at the bottom here, approach to asymptote, and asymptote the y equal to 0 here, and x-axis here. So either one, top or bottom. And second, you see between asymptote line, the pink one, asymptote and the blue here, they cross here. So the graph should be happen in on the top, or either on the bottom. Okay, don't forget asymptote, the graph won't cross, but approach closer to asymptote line. So you see this side, so this side we can design right away because we have y-intercept. So the graph should be somehow like this right away. Okay, you cannot be this way, because this way, that means this did not close to asymptote at all. So now this side, you actually, you know right away, the graph should be like this right away, because you know y-intercept, and this asymptote. So the graph approach to asymptote, so gonna be somehow like this, like a curve, a little bit curve. Okay, it should be a little bit curve here. So you can draw like this right away, and the graph gonna the curve should be curve. Okay, approach to asymptote line, and this side approach to this vertical asymptote. Okay, so we take it easy now, right? So we got one side. Now that means the top doesn't have any more. Okay, because we don't have any intercept. The graph step right here, so it should happen in here. Everyone get it? Because approach to asymptote both sides here, pink and the blue here. Okay, so the top shouldn't be there. Now you see on the right hand side we don't have intercept, right? Because we find here doesn't have intercept. So now what we can do is you can add or substitute replace any value of x on the right hand side here to the question, to the original question, see where they can go. Can be, this one can be only two shapes can go, is this curve like this or go down like this. Okay, but now we want to find out which one gonna be. So we just replace this one. The most easy, I start on x equal to 3 here. So you replace 3 in here to the original question here, right? So then say if x equal to 3, if x equal to 3 here. So let me write down here. So if I want to find the point x equal to 3, right? Replace in this function g of x, right? So equal to 3 over x minus 2. So g of 3, right? When x equal to 3, so then you replace this one, 3 become 3 minus 1 minus 2. So become 3 over 1. So x equal to 3. Now we know when x equal to 3, go up to y, 3, 1, 2, 3 here. So you got this one right away. Okay, now, because we don't have intercept, no y-intercept this side, right? So my graph, I can guess right away, should be like this, right away, approach to asymptote here, and approach to asymptote on the bottom. Because they won't cross asymptote line, okay? Everyone get it now? So that's all finished for this question. When you plot graph, it's really fast. First step, find asymptote. Second step, find x and y-intercept. Next step, plot the graph by side, 1 or 2 points from the left, from the right. And like this one, you can observe from the asymptote right away. Okay, now this one, how to work on how to plot graph. Now find domain. Find domain, what the domain, final answer. Domain, you see that this is a goal y, right? And this is a goal x, right? And then this side x, this one x, y, and go down y. So domain, you read the value of x. So x come to this side, that means plus infinity, and x go on the left hand side, negative infinity. So that means domain is what? Domain equal to all real number, correct? You can write R represent all real number, all real numbers, okay? And then, but the graph x never go at the x equal to 2, then you have to write down, say, except x equal to 2. So that's the answer for domain. So you can write down, say, domain is all real number except x equal to 2. That's all. Or you can say, you write down domain, maybe that way better, okay? You can write like this. You can say that like in the set pattern, real number, right? Except x equal to 2. Can be either way, write it down. Okay, just give you, answer clearly the most you can. I think that's all for this question of the podcast. Okay, so we see next example. Okay, so next one.